Hi, this is Chuck Benedict, mentor for Team 997 Spartan Robotics in Corvallis, Oregon. Thought I would take my last video, and if you've stuck with these videos through the whole series, I appreciate it. It's taken a lot of work to do it, and if you liked what you saw, hit the like button. Please leave me some comments. I would be interested to hear your feedback. But in this last video, I thought I would go through some automated tests that I've written for the project. I've been promising these for a bunch of videos in the past and finally decided to sit down and do it. Let's talk about automated testing for just a bit. Programmers on robotics teams, they have to be patient sorts because they spend a lot of time writing code and they have a hard time seeing it actually do anything, because typically the robot's under construction for 75 to 95% of the build season. So having components to actually deploy code on and see the results of your work takes a lot of patience, because it takes a long time to get to that point. But one of the things that you can do is use the testing capabilities that are at your disposal. I think testing gets it doesn't get this respect that it deserves, and in particular for robotics students, you can use automated testing to get some instant gratification. Yeah, it's not as fun as seeing the robot move, but on the other hand, actually being able to run your code and see it do what you think it should do is also pretty rewarding. And automated testing too is repeatable, so as you make changes to your project over time, you can easily see whether you've broken something. And typically you do. When you make a change to something, it may affect something else that you didn't really expect, and you can catch that before you deploy your code onto the robot and make a mistake in competition. So having said all that, I thought I would go through a couple of examples of some automated testing that I have done with the image processing sample project. And there's two things. One thing in particular that's important to understand, and JUnit, which is the other, is a Java testing framework that's been out for a while. Microsoft recently released a plugin for VSCode. I would say 3 or 4 months ago, where if you have a JUnit backed class, and you back your classes for JUnit by simply importing JUnit, you don't have to implement or inherit anything. Simply all you have to do is put a decorator above a method that you want to run as part of your test suite with *test, and the JUnit runner built into VS Code automatically picks this up, and very nicely for you, it automatically puts in these helpers that allow you to simply run this one test or debug this one test. And if you hit debug, it'll actually step in to this code in the debugger, and you can just basically run it from right here without having to do anything else. It's really nice. The second thing that you really need to effectively test is what's called a mocking framework. There's as many mocking frameworks as there are religions. I happen to use one that I found that resembles the mocking frameworks that I've used in C#. The one that I'm settled in on is called Mockito, Mockito. There's a bunch of other ones out there, and if you're a longtime Java programmer, you probably have your favorite. Use what suits you. Mockito suits me because of its domain-specific language. It's DSL. It seems very intuitive to me, so that's why I find it useful. And the reason that Mockito is useful is because when you're trying to test something, one of the most difficult things when you're writing automated tests is trying to decide what it is that you want to test. Are you trying to do a unit test, an integration test, a system test? The point is that you want to try to pick what it is that you're trying to test, and then only test that thing and the one thing that you're trying to test, as opposed to trying to test the whole world. And in particular, the more granular your test and the more of a unit test that it actually is, the more you want to remove all the dependencies that could cause that unit test to fail, because it only serves to confuse you if your test is failing. If you're intending to make it a unit test to test a very narrow thing, yet some external dependency is causing it to fail, then it may lead you to believe that the code in your unit test is failing as opposed to it failing from the outside. So a mocking framework gives you the ability to mock out those external dependencies so that you can focus on only that thing that you care about in your test. So also testing, deciding what it is that you want to test is also sometimes difficult because the design of your class has to have some forethought put into it to make testing easier. So develop for testing or design for testing, that's something you might read about. Your class, if your class has external dependencies, the general rule is you want to inject or send in those dependencies, typically in the constructor, and then have your class work with those dependencies. And if you do it in that way, that gives the mocking framework the ability to inject or alter those dependencies at test time so that you don't have to actually have one of those actual dependencies instantiated and built. You can use the mocking framework to build the dependency and just wire up those things inside the mocked dependency that you need to run your test. So that's a lot of words. I didn't really mean for this to be a lecture on testing. So let's get in and look at some code on the Vision project. The first example that I want to show you, if you've watched my prior videos, I talked about using network tables for this project to write the result of the image processing. And in particular, I created a interpreter class that interprets the results of the image process and basically surfaces those results so that you can write them to network tables. I've also created a NetworkTableWriter class that essentially all it does is it takes that interpreter and it takes the network table that you're trying to write to, and it basically does the writing to network tables. So this class here, NetworkTableWriter test, it essentially tests that that writing is done inside the NetworkTableWriter class. So the class itself is very simple, and this test is very simple, but I think it shows you the power of being able to write these things very, very simply as well. So first thing, my test here is called it writes ball found result. So I interrogate the blobs that come back from the Vision pipeline to see if there are any in there from finding racquetballs. And what I'm trying to do is write a true or false Boolean into network tables for a ball to signify, yes, I found one on a frame, or no, I did not. So I want to test finding a ball. So I've got my ball found true up here. So the interpreter, I want to mock the interpreter because all I want the interpreter to do is to just return for me whether or not a ball was found. And I don't want to have to hook it up to an image pipeline to make that determination. I don't want to run my image pipeline through an image, and I don't want to have to do all that to make this test work. I just simply want my interpreter to come back and say, yep, I found a ball. So I'm using Mockito to mock my interpreter class, and then this little DSL language here, when interpreter mock.balls found. So when the balls found method is called on the interpreter, then I want to return this Boolean ball found, which I defined up here, true, in other words. So now when this method is called, I'm going to get back this result, and I didn't have to instantiate the interpreter class, and I didn't have to send all of its dependencies and all that stuff, which makes this unit test really simple to do. So network table, I have to mock it as well. And again, I don't want to have to connect to the RoboRio. I don't want to have to start a fake network tables process. I don't have to do any of that. I just want there to be a network table class out there because ultimately what I'm looking to test is, did I call put Boolean on my network table? That's what I'm trying to see, whether or not my writer did its job. So I'm not even going to mock up anything on network tables. I basically just want the interface. I don't want Java to crash whenever put boolean is called. I just want the interface to exist, and that's what this mock will do for me. So now I want to wire up my class under test, and in this case, what I'm trying to test is NetworkTableWriter. Now, if I were to just instantiate that here, in fact, let's go pull up NetworkTableWriter. So NetworkTableWriter is actually an abstract class. So if I were to, in my test, instantiate that class, Java wouldn't let me. It would say, you've got an abstract class, you need to create a concrete instance of it. If we go down here and look at what's abstract, you can see that I have a getBallFound key and getBallCount key. And the reason those are abstract in this class is because I'm interpreting, I need to do interpretations on blue balls and red balls. So I want different keys to tell me whether or not I've got blue balls found or red balls found. And in prior projects, if you looked at my code, you saw where I duplicated some of this. I had some duplication. And so I tried to dry this up. Don't repeat yourself, dry. I dried this stuff up such that I could do this work here without having to repeat it, but I needed a way to abstract out the key names of the balls. So that's why these are abstract. And if you go look over here, you will see a blue ball network table writer class, and simply all it does is it gives me the key names back. This is basically a concrete class of the NetworkTableWriter. Now, let's go back to the test. So you could say, okay, well, if you need a concrete class, why don't you just use the blue ball class or the red ball class? Again, thinking through what it is that I'm trying to test, I'm not trying to test whether I get back the right key name. What I'm trying to test is, does the NetworkTableWriter class itself work? So what it means is I need a concrete class that's irrespective of whether I'm dealing with blue balls or red balls or whatever kind of balls. So for the purpose of this test, what I decided to do is just create my own concrete class, which is defined here, and I basically just give it some arbitrary keys. Now, some people say, well, why did you go to that trouble? Just use one of the other ones. I could do that. But what if I change the keys on one of the other classes? And then that in effect could break this test. And that's an example of making a change to a dependency that's not really relevant for the specific purpose of the test that you're trying to do. So that's why it's important to retain control of dependencies so that you know for a fact when those dependencies get used or injected that you know what they're going to be. So that's why I created my own concrete class for the purpose of this test. Okay, so this is my class under test. So now finally I just want to act, and I want to call the write function on the writer. Now all I want to do is verify, did the put boolean function get called as part of the writing? So down here, Makito provides a verify function. I want to verify the network table mock, and I want to know whether or not on that function something was called one time. That's the times one. And the something that I'm looking for is the method put boolean. And in particular, when put boolean was called, I want to know, was it called with the key that my network table writer exposes? And in particular, I want to look for the ball found key. And when we wrote to that key, what did we write to it? Well, we wrote ball found, which was defined up here. So the act of doing this verifies that the writer did what I expected it to do. So let's just run this test and see what happens. All right, the test ran. My green check mark is still here. That tells me the test was successful. If I click the green check mark, here's where I get my gratification that says that my test passed. That's all great. Let's make this fail and watch what happens. So we're going to normally return ball found true, but let's change my verification to false. And let's rerun this and watch what happens. And this is, this happens to me a lot. If you don't save your change, you're going to get the test run with the old one. In my case, when I move off the pane, I autosave. That's the setting I've got set in VS Code. So beware when you do that. That trips me up frequently. There we go. So now I got my big red X. Click on the X, and I see a failure. Uh-oh, what happened? What failed? Well, my arguments are different. What I wanted was making a call to put Boolean ball found false, but instead what I actually got was ball found true. So, and it gives you the line that it happened on and so forth. So automated tests, this is just a great way to get early feedback on your code to make sure that it does what you expect it to do. Make this change back so that this test doesn't fail in the future. Okay, so that's an example of one test. Let's go look at maybe a bit more complicated test. So I created, so in prior videos, you may remember I did some performance tuning. And in particular, I'm doing two image pipelines. I'm looking for blue balls and I'm looking for red balls. And I decided to do those operations simultaneously in my processing loop because I've got a quad-core processor, so I can make those cores work on things simultaneously. And in addition, what I also found is that I/O was taking a while to actually read frames off the camera. So I decided to actually do all three of those things simultaneously. In my processing loop, process red balls, process blue balls, and tee up reading from the camera to get the next frame. So in the act of doing that, it created what's called an image pump class, which in a multi-threaded way goes off and calls the grab frame method on an image sync and tees up the frame that it gets for the next time around the processing loop. Inside the pump class, and let me go ahead and bring that up instead of talking about it. So inside the image pump class, there is a method called pump. And here you can see the grab frame method taking a reference to an input image because it's going to fill this input image with the image that it pumped. And it is all doing this in the context of what's called a future. And I'm not going to spend a lot of time talking about what a future is. I did that on prior video, but this is an asynchronous call that is going to go off and call grab frame, and sometime in the future you're able to get the result from this future, which will be the image that you're interested in. What I'm trying to test though is, does my image pump class actually pump the image? In other words, does it call grab frame and does it give me back the next image from the image sync? And when I test this, I don't care that I have an actual image sync that's hooked up to a camera. I'm not trying to test whether that works or not. All I'm trying to test is, am I grabbing frames correctly? So back to my image pump test. If you think about this now, that, sorry, let's go back here. This frame is going to get filled up by the sync, but if I am not going to wire up the sync to actually give me frames, how am I going to make my test work? I need to mock this input image in some way so that I can predict and know what it is it's going to give me, so that when I actually test the result of pump giving me that image, I know what it's going to give me. So that's a little trickier to do because you have to catch the act of the grab frame method actually doing something, and you need to substitute in what it's doing with your own work. And the way that you do that is through what's called an answer. So you can substitute the answer of what the invocation is to grab frame with this override here. So you're going to get an invocation. So when the grab frame method is called, you're going to get what's called an invocation, and that's going to allow you to get the arguments to the grab frame call. You get one argument, which is the image sync, And in this case, what I've done is I've mocked an image up here. I've created basically a 3x3 matrix. It doesn't have, it has all ones in it, but it gives it a size that I can interrogate of 3x3. And what I do is that I get the argument that this invocation has filled in for me. It's the first parameter that's been passed, and I copy the mocked image to the mat, which is the input image on the grab frame method call. And by doing this line right here, that guarantees for me that this is the image that I'm going to get back from the pump method. So now then, the rest of this becomes easy to do. I'm going to wire up my image pump, and I'm going to pass the image sync that I mocked back up here in, because that's what image pump takes. Its dependency, and this comes, this is where dependencies are important. Its dependency is an image sync that it's fully formed, if you will. So I pass in an image sync to the pump class. I call pump, and now down here, when I'm checking my assertion, I am checking that the image that I got back from this future, that the size of it is equal to the mocked image size that I created up here. So this is what's telling me that I got back an image that I expected to get back because I had mocked it up here. So this kind of work is a little tricky, and you typically may not do something this sophisticated, but this gives you a little peek as to the power that you can do to not have to do things like mock-up image syncs and mock-up camera sources and have a camera plugged into your workstation to be able to actually run the test to see whether or not you're able to get images off of an image sync. Final test that I want to show you, which is probably the most useful test, is running an image through your image pipeline and seeing whether or not you get back the result that you expect. So in this case, I'm not really using Mockito to mock up anything. I actually want to instantiate the pipeline. I want to use OpenCV to make a determination, and I want to see if it actually processes the result. I would actually call this maybe not a unit test. It's more like an integration test because it requires some external dependencies to actually make the test work. In this case, the dependency that it requires is an actual image itself. So what I've done is I've created two JPEG images of balls, a lighter one and a darker one. And I did that because I was noticing that the light exposure made a big difference as to whether or not my pipeline was going to work. So again, huge benefit of automated testing. You can create as many tests as you want with different exposures and tune your pipeline and run your tests to make sure that all of those combinations result in it detecting your image properly. So let's go in and just take a look at a couple of my balls. So I have a darker image here that looks like this, and I have a lighter image here that looks like this. And indeed, one version of my pipeline, one was succeeding and one was failing. So, and I probably am going to add more tests here with maybe the white balance changing and so forth, so that I can really get this dialed in. But as you can see here, I've got a test called it should find red ball with darker exposure. OpenCV has a class that allows you to take an image in JPEG or PNG or whatever and read that into a fully formed mat format, a matrix format. It's on the image codecs class, static class, and they've got a method called ImRead, stands for image read. It takes a string for where your image is located. I didn't want to have to put a fully formed path to my image, so I use the file class with relative reference to find my image. And get canonical path actually gives the full specification for the image. So now I have a mat. I'm going to instantiate a pipeline, my red ball grip pipeline, which is basically read directly out of grep. I didn't make any changes to it, and I did that on purpose so that I could always recreate it. I'm going to instantiate it, and then I'm going to call the process method on it, and I'm going to give the image that I created up here. And then I know that my last call on the pipeline is to find blobs, because I'm trying to find the balls on the image. And in this case, those images that you saw, I should find one and only one red ball. So I'm looking at the total count of the blobs on the pipeline, and I'm comparing that to 1. So let's go ahead and run this test. Green check mark, everything worked. That's so nice. I have my test passed here. Let's run them all, actually. So you also get a little helper on top of your runner class. When you hit run test here, this will run both of these tests. So I got green check marks on both. Again, if you see a failure, so let's make this fail. Oh, caught me again. It didn't save my change. All right, I have failure. Let's look at what it says. Expected 0 but was 1. And this brings up a kind of an important point. A lot of these assertions, assert equals is one of them, where you have two values, what you expect your result to be and what it actually is. It took me a while to remember this, but you always want to put what your expected value is in the expected place and what your actual value is into the actual place, because anybody else that's looking this will get confused if all they're doing is reading the message and you have these things flipped around. So in this case, I am expecting 1 to come back, and this is what it actually is. So make a conscious effort to not get those two things confused when you use assertions, because many assertions have an expected and an actual associated with them. You could use assert true here and do 1 equals total. When you do that, though, it takes away this notion of expected and actual, which I find a little more confusing. So I try to stay away from assert true and use things like assert equals. Okay, that was, I think that's all I have to talk about. I guess one final thing is, you'll notice that I'm using OpenCV to do this test. You are probably well aware by now you actually have to load the OpenCV native dependency, the DLL, of the image processing primitives, because OpenCV is not fully implemented in Java. It relies on some C++ to do its work. So you have to call this load library function anytime you do any image processing. This in Java applications, this is normally done for you, so you don't usually have to remember it. The first template applications already do this for you. But if you're going to run tests, you have to remember to do this. Next thing, though, is the helpers up here. These helpers, when JUnit is run under the cover from VSCode, these helpers won't, say another way, JUnit will not know where this OpenCV DLL is located. Thus, when you run these helpers, they'll fail. So it's easy to fix, but it's not easy to know where to fix it. Where to fix it is in launch.test.json, which is in the .vscode directory under your project. And you'll get two configurations, a run configuration and a debug configuration, which makes sense because you have a run test and a debug test. These configurations normally will not, this env variable, there normally won't be anything in here. As you can see, I have added a path environment variable, and I have given path the location of where my OpenCV DLL is located. And if I go back to my project, I will show you that the act of building my project creates a build directory, and it creates under the build directory an OpenCV directory, and there is OpenCV Java 310.dll. And so the JUnit runner needs to know where this DLL is located, and thus that's how setting the path, that's how JUnit knows where to get it. Finally, one more change. You'll notice this default parameter. This parameter is normally blank, and if you run tests with the test explorer, here's my pipeline test. If I right click and I say run with config and I click that, I get it knows, the test explorer knows that I have specific configurations defined under the camera vision project, which happens to be these two configurations. However, JUnit, the JUnit runner, doesn't know that which of those configurations to use, and it will use a blank configuration essentially. So you need to tell JUnit which test configuration to use when you click run test, and the way you do that is you tell it the default configuration is camera vision, which corresponds to this name right here. Okay, you do those two things, then your helpers will always run, and you can run tests on demand on the fly. So a final thing is, do you have to specify a fully formed name here, or can you use $ workstation directory or whatever the variable is? The answer is doesn't seem to work, and I put an issue out there for Microsoft to tell me whether or not that's supposed to work or not, and if it doesn't, to please add it, because anybody that downloads this project, they're going to get my fully formed directory here, which of course won't work on their workstation. So that's kind of annoying, but it is what it is. One last thing, and I promise I'll end this video. If you want to run all of your tests, down here in the command line, there is a task on the Gradle build system called test. You can run Gradle W test, and what that'll do is that will go through your well, actually it goes through both directories that have Java code in them, and it will interrogate all the code with test, here we go, with test decorators, with methods with test decorators, and it'll basically run the test. And you'll get some reasonably helpful information as to whether or not they pass or not. You may have also noticed that I tend to be very verbose with my test writing in terms of I have some duplication, and the reason that I have it is I only want to test one and only one thing at a time. I don't want to load up all my tests with doing a bunch of different things. Of course, my tests didn't run because I haven't made any changes to tests. Sorry about that. Let me make a change to a test and make it fail. I'll come back to what I was talking about. So, forming tests that may be duplicative, it's easy for me to say. The reason that I do that is because in my runner down here, when they run, here we go, the runner will print the name of the tests. And as you can see down here, here's my names, and it tells me whether or not the tests passed. And so if you're good with your names, you can very quickly down here look at what the test runner does and know exactly which test is failing. If you write one of these tests and you overload them with checking a bunch of different things, the name of the test, the meaning of it kind of becomes lost, and then that leads you to like, oh, so what exactly in that test is failing? If you just focus on testing the one thing, you'll know, oh, that's the one thing that's failing when you look at failures down here. Okay, promised that I was going to end. With that, I end. I hope you find this useful. In the comments section of the video, I'm going to put some references into Mockito and to JUnit. There's a bunch of great tutorials out there. I suggest you go out and do some reading on them, and that will make writing tests really easy for you. Thanks again for watching.